All right, people, you have been learning about how to convert back and forth between logarithmic equations and exponential equations, and the other way around, of course. And so now we're going to take a look at, well, what can we do with that? Well, just imagine a situation where you have $1 million. Yeah, you have $1 million. Of course you have $1 million. Why wouldn't you have $1 million? And so the $1 million is your starting amount, and we'd eventually like to get 4 million bucks, right? Duh. And let's say you find some opportunity to invest where you believe on average you will be able to get like 7 or 8 or 9% per year return on your investment. Okay. Now, I don't know where this magic investment is, but if when you find out what it is, let me know, please. In the meantime, let's assume that we found one. Okay. And then what we would like to know is we'd like to know how many years will it take to turn $1 million into 4 million bucks. Well, what you can see here is I've written it all out as an exponential equation. I'd like to remind you that with exponential equations, we always start with the beginning amount over here, just to the right of the equal sign. We will multiply that times the 1 plus the growth rate. And then we will raise the 1 plus the growth rate to a power. And by the way, of course, we do all of this stuff first and then multiply times the million. PEMDAS says, do everything in parentheses first, then exponents, then multiply. Okay, but just so that you're with me on why I've written it out this way. 1 million is the starting amount. 1 plus 0.09 is the how much it'll grow by, and then t will be the number of years, and so we keep multiplying 1 million by 1.09 for as many years, and that's exponential growth. Then we know that eventually we'd like to get 4 million bucks. Now, you'll notice that the only thing we don't know is the number of years. That's what we're trying to find, and you can see it's t, it's the exponent here. Okay, so what are we going to do? Well, first let's simplify. Let's use all the training that we've ever had as a math student. And we'll begin with the idea that if we want to solve for a variable, one of the keys is to isolate the variable. So we want to get this t by itself. Now, many times when we're trying to isolate a variable, we don't start with the number right in front of the variable. We start, further out. So in this case, we're going to try to get rid of that million first. And that's going to be really easy because I can just divide both sides of this equation by 1 million. And if I do, that 1 million goes away. Yay. And there's like a really lovely thing that's happening over here on the left side as well, is we've got 4 million divided by 1 million. That math is easy. And the result is even better. It's simply the number 4. So yay. Things are looking good here. We no longer have a million here. That cancels. We get a 1 here and a 1 here. And those ones essentially disappear because we're just multiplying and dividing by 1. It's just like doing nothing. Okay, so 1 plus 0.09 is something. That is 1.09. And then t is still there, so we'll leave the little t there to the power of t. Now, this is beginning to look a little bit like an exponential equation that we've been looking at. I'm going to flip things around so it looks exactly like what we've been looking at. We'll put the 1.09 raised to the power of t on the left, and we'll put the 4, or the number, on the right. And then it begins to look like the stuff we've been doing, like where we had 5 to the power of 2 equals 25. And we said we could rewrite that as a logarithm. Well, it's kind of nice to have it written out like this 5 to the power of 2 equals 25, because then we can do the Weingarten whirl. And if nothing else, it's just fun to say and fun to think about. Now, if you haven't figured out what a whirl is yet, you might want to Google it or Siri it. Anyways, so we're going to make this into a log. Here we go. So when we go to make it into a log, what we do is we say 5, then 25, then 2. So log base 5, and that'll be the base of the log, of 25, and I should probably be making that a little lower, and then 2 is equal to 2. And the way we say this is log base 5 of 25 equals 2. And the 25 is not an exponent of 5. The bottom of the 25 is supposed to be the same as the bottom of the log. And the 5 is a little smaller than the 25, and it's down below the log. It's known as a subscript, okay? Log base 5 of 25 equals 2. I'll remind you that the 5 is the base of the exponent. The log, the whole log, including the base and the 25, also known as the argument, this whole log is the exponent, and it happens to be equal to 2. Okay, so all we did was we rearranged things so that we could do the Weingarten whirl over here. That's why we did it. And strangely, when we do the Weingarten whirl, we're going to end up with a T somewhere. So we're going to try this and see how it works. So I'm going to go ahead and write with a different color since we're about to make some progress here. We are going to write log a base 1.09. That's a little strange base of 4. There we go. And that will be equal to T. And this is the beauty of logs, is up until now, we would have had no way to get that T all by itself. But because of logs, when we convert an exponential to a logarithmic equation, the exponent just separates out. We just get it all by itself. So yay, we're so happy. Now, the only problem that we've encountered is we don't know how to figure out what log base 1.09 of 4 is. And that would be really helpful if we did. The good news is that if somebody asked us how many years would it take to turn 1 million into 4 million with 9% interest per year, we could tell them an answer. We don't know quite what our answer means, but we could say that the number of years will be log base 1.09 of 4. Yay! We could even box that answer. We're so happy. Now, I know that some of you are curious. You're thinking to yourself, Weingarten, I'd really like to know how to tell what number log base 1.09 of 4 is. And for you, I'm going to show you. Here we go. So I'm going to be honest with you. Our calculator has no idea how to do log base 1.09. But our calculator does know how to do a couple of other cool things, and we'll only talk about one right now, and our calculator does know how to do a log. So you may notice on some scientific calculators, they have a button that says log. And if you press that button, it will calculate the log for you. The only thing is that log button will only calculate the log when the base is 10. You notice our base is 1.09. It is not 10. So if we press this button, what happens is we'll get the answer if we do 10. Now I'd like to remind you something here. Let's try to do a couple of log base 10s in our head. If we do log base 10 of some number, let's try like 100 just for fun, okay? Let's say we want to know what is the result of log base 10 of 100. You don't need a calculator. I'm telling you right now, you can do it in your head. Because we already said that this log, this whole thing, is simply the power of 10, the exponent of 10 that gets us 100. And I believe you might know what that is. Hopefully you said, well, let me go ahead, hold on, let's see if I can get rid of that for a minute. I hope that you said that the answer is 2. And if you did, then you know how to do logs in your head. Congratulations. Maybe we could do another one and see how good you are at that. How about this? What if we wanted to do log, I'll give one that's simple and then we'll give one that's harder. What if I want to do like log base 10 of 10,000? I wonder what you might think the number is here. You can pause the video and see if you can figure it out. No calculators. Okay, I'm hopeful that you try it on your own. I believe the correct number we're looking for here is 4. Log base 10 of 10,000 is 4 because if I raise 10 to the power of 4, I get 10,000. Now, let's try a couple tricky ones just for the heck of it. What about log base 10 of 1? What do you think that might be? Pause the video, see if you can figure it out. I'm about to tell you. Drum roll, please. It is 0. If I raise any number to the power of 0, I get 1. So yay. Okay, so that's some fun with logarithms. But now let's figure out a way to convert our log into a log base 10, and then we can use our calculator to get the answer. So we're going to go ahead and say, I'm going to give you a formula. Here we go. Okay, so we're going to do something that's called the change of base formula. The change of base formula lets us take a log that looks like this, and I'm telling you, I believe that this guy up here looks like that. Okay, it's got a log, it's got a base, it's got an argument, log base m of n. Okay, so they are kind of similar. If we have something that looks like this, we can break it up into two logs. We can break it up into log of n over log of m. Okay, notice how the n is sort of higher up and the m is a little lower down. Well, log of n is on top and log of m is on the bottom. And some of you might be wondering, well, where'd the base go? Well, it turns out that there is a common convention amongst mathematicians that if you write log with no base, we assume that the base is 10. Sort of like if we write a square root, we assume that there's a little 2 over here that we don't talk much about because later on when we learn about cube roots and fourth roots, there is a number there. Okay, so anyways, for us, if we have a log by itself, it's log base 10. So log base 10 of n divided by log base 10 of m will get us the same answer as log base m of n. Now, just in case you don't entirely believe me, we can test it. There is an easy way to test this. And let's just do a quick practice and then I'll erase it. In our heads, we know log base 3 of 9. We know what that is. We know the answer. The answer is whatever power of 3 gets us 9, and that's going to be 2. So we could easily test to see if this formula works by doing log base 10 of 9 and on our calculator and divide by log base 10 of 3. And supposedly the answer would be 2. Now, I'm just telling you how you can prove it, but I'm not going to do it with the calculator right now because the clock's ticking and I know you don't want to watch this video forever. Okay, now, if you do try to do this on your calculator, make sure you use parentheses on the bottom here. Otherwise, you may get the wrong result. Oh, and you might want to use parentheses on the top as well, just to be safe. Otherwise, you may not get 2 and you'll be like Weingart and you're lying. Okay, so let's get back to business here. Now, what we're going to do is try to evaluate how many years this is. So what we're going to do is we're going to say t is equal to not log base 1.09 of 4 anymore, but it's going to be equal to log of 4 over log of 1.09. Okay, now we'll have to, and the result we get is going to be, we're going to round it because there's going to be lots and lots of decimal places. So we won't be saying equal anymore. We're going to have to say approximately. And the approximate symbol looks like a couple little waves like that. Now I'm going to have to break out the calculator and let's see what this is. I don't know about you, but I am so excited. I wanted to show you, I wanted to actually press the buttons while you were watching. I am using the calculator on Windows, which is the computer I'm using. I'm going to go ahead and try log of 4. And oh, see, it doesn't like that. I'm already misusing the calculator. I'm going to have to put in the 4 first. Different calculators work in different ways. And then I hit the log button. And then that gets me a number, 0.6, blah, 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 blah. Now, we don't know why log of 4 is 0.6, blah, 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 but it is. And then we're going to go ahead and say divided by. And for me, just to be safe, I'm going to use parentheses. And I'm going to say 1.09, and then I'm going to hit log. And I get, what do I get? 0.03, blah, 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 blah. Okay, so it looks like I might not have, I may not have needed the parentheses, but I'm going to go ahead and finish the parentheses just to be safe. And then right now what my calculator is doing is it's doing log 4 divided by log 1.09. So here we go. I'm going to hit equals, and let's see what we get. And the answer is 16.08 blah, 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 blah. Now, I don't know about you, but I find this to be extremely cool because essentially what we just learned is that if we have $1,000,000 and we invest it at 9% interest, and we just leave it there, oh, I'm sorry, we don't just leave it there. We want to know when it's going to turn into, when we want to know our $4,000,000, when it's going to turn, when we want to know when our $1,000,000 is going to turn into $4,000,000, we just figured out it's 16 years. And that's pretty cool to me. Okay, now 16 years is a long time, but you know, look, we don't even have $1,000,000, so don't give me a hard time. Okay, so anyways, this is the magic of logarithms. I hope that you found it to be kind of cool. And if you did, I would love to work on some practice problems where we use our knowledge of logarithms to answer questions like this one. In the meantime, take good notes, take pictures of your notes, post them to this Google Classroom assignment, and take care.